धन्यवाद ये तुम चांस टे देल किछि कहिबा समस्ते आगु बहुत किछि कहि सारछंती मु ऑलमोस्ट सब लेक्चर मु अटेंड करिछि वेरी लकी फॉर्चुनेटली आम सब्जेक्ट मु जा देखिली जतकी एबे पर्यंत माने कुहा हैला सब सब्जेक्ट सहित लिंक फ्रैक्टल इमेज प्रोसेसिंग पैटर्न रिकॉग्निशन आउ से जियो स्पेशल इंटेलिजेंस उपरे जे कहिले हमर ये डॉक्टर पाणिग्राही खाली तुम टॉपिक टा छाड़ी करे सुधांशु मोटर और कौन कहला इलेक्ट्रिक ऑटोनोमस व्हीकल से भी किछि किछि लागी पारे मे बी वी आर यूजिंग जीपीएस तो रिमोट सेंसिंग एंड जीआईएस एबे इट इज एन यूनिवर्सल फील्ड और सबु सब्जेक्ट रे एसोसिएटेड होई पारिबो सो धन्यवाद बहुत बहुत धन्यवाद वेरी गुड आफ्टरनून को कोन कहा जेबो शुभ मध्याह्न शुभ अपराह्न शुभ अपराह्न तो किछि कहिबी इंट्रोडक्टरी रिमोट सेंसिंग आउ या परे ही बाकी किछि आरंभ हुए बाकी की माने मशीन लर्निंग डीप लर्निंग सेगमेंटेशन तो दिस इज जस्ट ब्रीफ बायो and I am editor in several journals. I am fed up little later. Already edited nearly 700 articles so far in the last 15 years maybe. Around 300 papers reviewed, 70 journals review karicham. So process is going on, and fortunately I have received also the excellent editor award also from many journals. So what is remote sensing? Remote sensing it is बहुत conceptually fundamental diagram. The definition टा होची मोडिया रे किछि लेखिनी, so I will also speak bilingual manner. Remote sensing is the science and art of obtaining information about an object, area or phenomenon. Phenomenon hela mane flood, landslide, disaster, soil erosion, drought, they are all phenomenon. Accident, area means any area. Upper lawn, lower lawn, playground, crop field, forest area. Object, telephone pole, ATM, whatever, a single object. So information about an object, area or phenomenon through the analysis of data. Which data? Remote sensing data. Acquired by a device. That device we call it remote sensor or sensor. And since it is called remote, सेटा से object, area or phenomenon सहित contact रे नहीं. So our camera जो photo नोची, that is also remote sensing. That is also remote sensing. So remote sensing can be terrestrial, a camera through रे. UAV around 30, 40, 50 meter height. Helicopter maybe 500 meter height. Aircraft 1 kilometer height. Space shuttle 200 to 400 kilometer height from the surface of the earth. Satellite 400 to 36,000 kilometer. So we collect remote sensing images from various level of altitude depending upon our requirement and techniques that we need to involve. So first is that we have a source of energy. Sun is the natural source. Depending upon the source of energy, we call it either passive remote sensing or active remote sensing. आमे जदि sun energy को use करूछु remote sensing रे, we call it passive remote sensing. But if we are using LiDAR, radar, or there are many other gravimeter, magnetometer, active remote sensing. Because that is the artificial source of energy. Sun is the natural source of energy. Concept is nearly same. The source of energy, energy passes through the atmosphere, it interacts with the earth's surface materials, retransmission होची, सही energy को आमे collect करूछु satellite, space shuttle, aircraft, drone or terrestrial camera. तापरे that energy is recorded either in digital form or in picture form. Okay, there are mechanisms to record either in digital form or in pictorial, just like image, photograph, print, say bolia. Then if it is pictorial form, we analyze it visually. If it is digital form, we analyze it using various techniques which sir has already detailed in the last lecture. All the topics are relevant to our subject. Let me tell you, whatever you discussed, maybe you should have taken 10 hours to discuss that. It is required also. ଆମେ ସବୁ ଟେକ୍ନିକ୍ସ ୟୁଜ୍ କରୁଛୁ more or less ସବୁ filtering, edge detection, segmentation, segment anything, ସବୁ almost ସବୁ କିଛି. I have used almost 50% of them so far. Our input is satellite data. Tapore we are generating different information products. If it is soil map. If it is forest map. If it is water bodies, different types of water bodies, like that. And finally, it is given to the user community. इसमें वो यह है क्या इसमें वो नहीं पॉइंटर नहीं, वो लाइट कौन सा है? अच्छा, next. So this is all remote sensing. Very simple, straightforward. Now, little more energy source, electromagnetic radiation, target, reflected energy, emitted energy, sensor, then relay satellite, then finally data product, and which we analyze. So in our subject, we deal with this. These part are dealt with by electronics and computer science people. Okay, they finally deliver this product to us, which we analyze. So these products could be either pictorial or digital, depending upon what we order and what is our purpose of analysis. So, take a introduction. So this is the both active sensor and passive sensors wavelength ranges which we use in remote sensing, starting from ultraviolet images to radar. So their wavelength ranges, band specification, thermal sensor, microwave sensors, visible sensors, laser fluorescensors which we use for ଯେମିତି ମାନେ ଶିପ୍ରେ oil spill ହେଲା କେତେ ଦୂର oilଟା ମାନେ spread କରୁଛି ଶିପ୍ରେ, that is possible to sense through laser fluorescensors. Techniques are again same. Whatever sir discussed in the last presentation, we are using almost the same techniques, and fractals could be another good technique there, I feel so, because oil spill uniformly spread করেনি. It does not spread uniformly in one direction. It's spread according to many parameters. So probably fractal could be a good technique to associate there. Ebe to gote spill hela na kichi mase 2 mas agre ebe due to this Iran and Israel war. So why I am showing this slide? This is important. So these are the wavelength ranges in the electromagnetic spectrum. ଏଇଟା ହେଉଛି atmosphere through ରେ ସେମାନେ pass କରନ୍ତି, କିନ୍ତୁ different wavelength ରେ different amount of energy pass हुए. Note that all energy, 100% energy can pass through in all the wavelength ranges. The next slide gives in detail. ଦେଖନ୍ତୁ ଏଇଟା. So these are the green means the energy which is passed in that particular wavelength through the atmosphere, and this magenta color is the energy which is blocked. That means if we want to sense here, keeping a sensor in the satellite or in the aircraft, we will not receive any energy because that energy is blocked by the atmosphere because of carbon dioxide and H2O molecule in the atmosphere. ସେଥିପାଇଁ ଆମକୁ ସେନ୍ସର ବି ସେମିତି ଡିଜାଇନ କରିବାକୁ ପଡିବ ଯେଉଁ ସେନ୍ସର energy could detect କରିପାରିବ. That means we have to design a sensor which will detect energy falling in this range. এই ওয়েভলেংথ রেঞ্জে, এই ওয়েভলেংথ রেঞ্জে, এই ওয়েভলেংথ রেঞ্জে। আর এই ওয়েভলেংথ রেঞ্জে যদি আপনার যদি ইয়ে মানে সেন্সর ডিজাইন করিবে, you will get zero values in the sensor. It will appear to be dark. That is the part of again electronics engineers. So এইগুড়াক some terminology which is fundamental terminology which we use in remote sensing: radiant energy, radiant flux density, irradiance. Irradiance means the radiant flux which is incident upon a surface, and radiance is the incident energy which leaves the surface. That is the two most important part are: one is irradiance, energy which is incident on the surface per unit area, per square meter, per wavelength, and radiance is the energy which is reflected or emitted from the surface per unit area, per wavelength. So this is how the radiant flux comes in a conical solid angle from the area. So this is the target. From here the energy is incident here, and from here the radiant flux is reflected or emitted, যেটা আমি সেন্সরে collect করো সেটা. This is the purpose of this slide. Then one more slide just to help understand how remote sensing and other sciences are related with each other: physical sciences, biological sciences, social sciences, remote sensing, GIS, cartography, mathematics and logic, remote sensing, photogrammetry. Photogrammetry is a kind of remote sensing. It deals with directly interpretation of a real photograph. So photogrammetry kuhajaye. So this is where remote sensing lies. This is where so mathematics and logic plays a very strong role. Okay. This is a slide to show that. So this is the sun, this is sun, this is a satellite and sensor. These are three ground objects. Gote building, gote gacha, or some fire area. So energy is incident on each one of them. Energy is incident of each one of them, and part of that is reflected and part of that is emitted, which is recorded by the sensor. Okay, this is another diagram to support that incident energy. Incident energy is a lake, water body, reflected energy from the surface, और किसी energy absorb होगा. That energy which is absorbed will be re-emitted, which we call thermal energy also. So for a black body, emissivity is 1. So absorbed energy is emitted energy for a perfect black body. For a perfect white body, emissivity is 0, no absorption. So all the energy will be reflected from the surface. So for a black body, all energy will be absorbed and they will be re-emitted. For a white body, no energy will be absorbed, all energy will be reflected, and there is no emitted energy. Most of the bodies or the objects on the earth are between black body and white body. That is emissivity varying between 1 and 0, not equal to 1 or equal to 0. Yeah, this is just, that is we call energy balance equation. Energy balance, that is the incident energy is equal to reflected energy plus absorbed energy plus transmitted energy. It is a good object hela, reflected, emitted, and transmitted to the next layer. Okay, there are different types of reflectance which takes place on the ground depending upon ground surface characteristics. Sir koile, there is that gray level co-occurrence matrix, GLCM. The smooth surface achi, which we call ideal specular reflector. If it is completely rough surface, ideal diffuse reflector. So যদি মানে রেডিয়েশন এমিতি আসুଛି স্মুথ রে রেডিয়েশন এমিতি ଯିବ. যদি সেন্সরটা যদি এইଠି ଅଛି, it will receive nothing. That pixel will become totally dark. Sensor যদি near perfect specular reflector, এইটি যদি সেন্সরটা আছে কিছু সে রেকর্ড করে নেব, little bit rough, it will be like they will be reflected in all possible directions. And completely rough surface, किछि ना किछि डोमिनेंटली से रेकॉर्ड करिवो सो सरफेस रफनेस एंड कैरेक्टरिस्टिक्स also play a dominant role on how much energy is recorded by the sensor. Okay, good diagram that where these reflectance are important. It is wavelength, x-axis is wavelength, y-axis is percentage of reflectance, visible, near infrared and middle infrared. तीनिटा माने क्लासिकल लैंड यूज लैंड कवर माने जोटा हम माने लैंड ऊपर थाए गोटे हला सोइल गोटे ग्रीन वेजिटेशन आ गोटे वाटर समिति तो हजार हजार प्रकार लैंड यूज लैंड कवर अछि बट वी हैव ब्रॉडली क्लासिफाइड एज सोइल ग्रीन वेजिटेशन एंड वाटर तो आपण देखंतु water bodies if it is any water body slightly even turbid also maximum reflectance is 10% at around blue range. And after 0.7, that is after red, there is no reflectance for water body, no reflectance. So if you want to detect water body, your sensor has to be designed to record the reflectance in this range. Maximum reflectance is around green, maximum is green. So you have to design a sensor so that it records the maximum reflectance around green region. Okay, your detector, crystal detector कहते ना अपन माने सेटा crystal detector made up of different kind of materials probably titanium कोन मु जानि से गुडा को but their sensor has crystal detectors and it is designed in such a manner you use such material which will be able to detect only radiation here. For soil it is a very long range. Anywhere you can design a sensor and it will record the soil reflectance. Green vegetation you see, so there is a depression and there is a peak. Peak and depression. Now the question is that if you record the reflectance here and if you record the reflectance here and if you record the reflectance here, you will not be able to distinguish between soil and green vegetation. It, or maybe around this also because the difference is not there. Difference nahi. So you have to use reflectance where there is a maximum separation. Maximum separation. नहेले आपनको किछि मिलिबो नै सेतले all will appear to be same. Yeah, this is another classical diagram which many people use. Coniferous trees and deciduous trees. So salo phale guडा deciduous, coniferous pine. From here to here, you see from 0.4 to 0.7 wavelength, coniferous and deciduous, almost having the same reflectance. Data collect karibo, you will not be able to distinguish between coniferous and deciduous. From here around 0.8 towards higher, larger wavelength, the separation increases. So if you use a wavelength of this portion, you will be able to distinguish coniferous and deciduous trees quite correctly. Okay. Yeah, thermal remote sensing. Thermal remote sensing means sensors designed to record the heat or temperature. Record the heat or temperature of the objects. Some objects are cooler. For instance, water body is cool, and bare and concrete rocks, they are hot. And vegetation is in between these two. What we need to understand? Midnight to next midnight. Midnight to next midnight. 4 a.m., 6 a.m., 8 a.m., 9:45 p.m., 12 noon, 4 p.m., 8 p.m., midnight. So, moist bare soil, the temperature is more or less same. Slight increase at 4 p.m. Metal objects, nearly same. Water, water is having a pattern like this. And this is that of bare soil or rock. And this is that of vegetation. The jeuthi vegetation, bare soil and rock and water semane cross karuchanti, that we call as thermal crossover. The thermal crossover area jodi apno sense karibe, you will not be able to distinguish between rock, soil, vegetation and water. We have to choose a wavelength where this much of separation exists. Dekhantu bare soil, vegetation, water, metal, moist, sabu kichi distinguishable. Then radiation law, 100% energy, I assume sun ro. So अर्थ उपरे एंड अर्थ तले केमिति एनर्जी डिस्ट्रीब्यूशन होउछि. So I will not discuss in detail केते एनर्जी एब्जॉर्ब होउछि केते एनर्जी हमको मिलुछि. तो हमको सेंसर पाए 71% एनर्जी मिलुछि. 29% energy is lost in the atmosphere and on the earth. Okay, and this will vary from one season to another season. Types of satellites, broadly, types of satellites. This is Earth. This is Earth globe, three-dimensional globe, and this is equator. This is equator. This circle is equator. East, west, north, south. So some satellites, जोटा मैं नियर पोलर और सन सिंक्रोनस सैटेलाइट कहूं, दे ऑर्बिट द अर्थ इन दिस फैशन फ्रॉम अराउंड नॉर्थ साउथ एक्सिस. North south axis. So earth is rotating, satellite is orbiting. Earth is rotating continuously, satellite is orbiting as long as its mission is not complete. Another type of satellite we call geostationary or equatorial. Satellite. So they revolve around the earth or orbit around the earth almost parallel to the equatorial plane at a height of 36,000 kilometers. 36,000 kilometers. So angular speed of geostationary or equatorial satellites and angular speed of earth is maintained constant. Angular speed. Tale kon hebo resultantly these satellites will always focus on the same area on the earth, because angular speed is same. So INSAT focuses India, Sri Lanka, Bangladesh, little bit of Pakistan and Nepal. So how do we receive information from one country to another country? So these are many geostationary or equatorial satellites are in orbit. Maybe more than 200-300 launched by different countries. Among countries are those. So there is a cricket match taking place here, somewhere here. So this satellite is recording the information. That means the video information is sent to this satellite. It passes to this, and wherever they want it, it will be beamed from here to that country. So these are all equatorial satellites orbiting around the Earth at 36,000 kilometers, spaced from each other at convenient distance. And they are also called relay and track satellites. Distance maintain होची obviously on the collide करिए ना. तो Earth, near polar satellite, equator. ए satellite होची move करूची Earth north south axis रो चारिपटे. So inclination of this satellite is nearly 98 to 99 degree. This is the direction of travel. One orbit of this particular satellite is 99 minutes. 99 minutes रे अर्थ से गुटे ऑर्बिट पूरा करे. So per day around 14 to 15 orbit से पूरा करूची per day. So every time it is orbiting, it is capturing one scene on the earth. Capturing one scene. এটা ভাবন্তু যে এটা first day first scene. First day second scene. Third scene. সেমিতি. Second day, first scene, second scene, third scene, say bolia. So we get a continuous coverage of the earth as long as the satellite is in orbit. We call SAM, it is called scene, an image taken by the sensor in remote sensing, we call it scene. That image we call it scene. That is the terminology we use. Scene means a particular definite area captured by the sensor of that satellite at a particular moment. We call it, it has a definite size. That varies from one satellite to another satellite. So just to help understand, or day 1 orbit 1, day 1 orbit 1, day 1 orbit 2. Kahin ke at a distance kahin ke ala? Kahin ke 99 minute ray, it is taking 99 minutes to complete one orbit. 99 minute ray, the earth has already moved by 2675 kilometers on equator. Earth is in rotation. Earth in rotation. So one orbit pura hela. One orbit pura hela. It completes one orbit. Now the satellite is focusing around this area. Now by the time it comes to the next orbit, see, this is not changing. This is fixed. Eta fixed eta. Earth is revolving. So next orbit parjanta, the Earth will have shifted to some other place. So west to east, and satellite is revolving around north to south continuously. तो गोटे ऑर्बिट रु नेक्स्ट ऑर्बिट पर्यंत अर्थ किछि मूव करि जिवो covering around 2675 km. No, first orbit ru second orbit पर्यंत first orbit ru second orbit आसिला पर्यंत Earth will have moved by 2675 kilometer. सेकेंड राउंड और फर्स्ट राउंड भीतर है जो अंतराल जो अच्छी सो दिस विल कंटिन्यू तो देखो तो डे 2 रे ऑर्बिट नंबर 15 इज कोइंसाइडिंग विद द ऑर्बिट नंबर 1 ऑफ डे 1 डे 2 रे अराउंड 15 ऑर्बिट 14 टू 15 ऑर्बिट 99 मिनट 24 आवर्स तो कहते हैं 14 ऑर्बिट. Now, there are two types of sensors or scanners in satellites. One we call whisk broom sensors or across track sensor. Another we call push broom scanners. Now, this is satellite. Here is the satellite. That is the sensor is just below the satellite. Sensor is just below the satellite or aircraft. So, in case of whisk broom scanner कौन हुए ना ए सेंसर ए भलिया स्कैन करे ईस्ट वेस्ट समिति स्कैन करे काहे कि सैटेलाइट पास करूची नॉर्थ टू साउथ सैटेलाइट इज पासिंग फ्रॉम दिस डायरेक्शन टू दैट डायरेक्शन सेंसर विल स्कैन like this. That is whisk broom. Another type of scanner is called push broom. सेतरे सैटेलाइट एमिति जाउची आ सेंसर भी से भलिया एमिति जाउची ता संगे जाउची. It does not move like this. सेमिति जाउछे तो दुईटा एक ब्रूम माने झाड़ू केमिति करा हो झाड़ू एमिति करू तो के झाड़ू से हिसाब रे one is whisk broom and another is push brooms are considered to be more efficient than the whisk broom. Another diagram to explain that. तो गोटे सैटेलाइट रा यूएस रो लैंडसेट 8 which is in operation. It has two types of bands. One is optical and infrared band, and another sensor is thermal infrared sensor. Optical or infrared nota band अच्छी और thermal रे दुईटा band अच्छी. Band 10 and band 11. There are wavelength range गुड़ा को एटी लेखा हुई चीज़. It's sun synchronous. Geostationary रो मो information बोलते देने मो किंतु एटा sun synchronous. Near polar sun synchronous. Equatorial geosynchronous always focused on the same area because angular speed of geosynchronous or equatorial satellites and that of Earth is same angular speed. So always it will cover one area. So our satellites are designed to cover India, little bit of Bangladesh, because of cyclone, tsunami, Bay of Bengal covers that much area. Tsunami can generate, cyclone can generate below Bangladesh also, below Thailand also. Record hochi even. This under. Now, so the big man is already listening. काहे के एबे जस्ट एप्रिल में पर्यंत तांको सैटेलाइट रो डाटा डाउनलोडिंग अनरेस्ट्रिक्टेड थिला एप्रिल में पर्यंत माने जे लास्ट सेमेस्टर पास करला ना तमे जत्ते चाहे सेते डाटा डाउनलोड एबे मु काली क्लास नेली पर दिन गोटे प्रैक्टिकल क्लास वन सीन फॉर वन स्टूडेंट सेमिति से रेस्ट्रिक्शन फ्रॉम वन आईपी और पे और पे और एसोसिएट योरसेल्फ विथ इसरो से तुमको जना पड़ी गला जे दुनिया सारा फ्री ये करू माने बिलियंस ऑफ डॉलर आसी बता पाखो को आसो नहीं आ कोन वन सीन फॉर वन डे वन सीन रे कोन हेबो रांची एरिया कवर हेबो जनो जे पटना काम करबो त का ऊपर डिपेंड किनिबा को हेबो दे आर एबे से माने फ्री करू छंती धीरे धीरे से माने एबे हम इंडियन सैटेलाइट भी रिजोल्यूशन बढ़िया अच्छे इट इज बढ़िया अच्छे एबे किंतु से माने अनरेस्ट्रिक्टेड देई नहांते एबे पर्यंत देई नहांते आर रिजोल्यूशन अराउंड 250 मीटर रू 1 किलोमीटर नॉट 250 मीटर रू नॉट बिलो कहीं कि से सैटेलाइट गुड़ा को वेदर फोरकास्टिंग टेलीकम्युनिकेशन ये कौन कहती ये डिजास्टर मैनेजमेंट ये भाया यूज हुए से डाटा गुड़ाक नहीं एबे से भाया सेंसर इलेक्ट्रॉनिक्स लोक मानकर काम से के जानी होइथिबो जेमिति क्विक बर्ड अच्छी ये रशिया रो तो तार रिजोल्यूशन अच्छी 40 सेंटीमीटर हाँ 40 सेंटीमीटर and 1 square kilometer if you buy that is $1,000 1 square kilometer area $1,000 सेमिति चार्ज के कनिबो 36,000 अरे सही डिस्टेंस रे you can imagine the perimeter केते देबो 500 कि 600 टा थिबो मैक्सिमम गार्बेज बढ़ुछि गार्बेज तो बढ़ुछि काहे कि सेवलक तो एक्सप्लोड होई जाय तांकर सरीला पड़े सेठी
गोटे सैटेलाइट आउट सैटेलाइट पाइका थ्रेट गोटे डेड सैटेलाइट गोटे लाइव सैटेलाइट पाइका थ्रेट
हां होई पारे सेति से ग्रेविटी मीटर थ्रू डेब्रिस गुला को सामने बाहर करूछंती
नहीं एपे गोटे वर्ड यूज करते से माने ऑर्बिट वार नुवा वार गोटे नुवा डोमेन ऑफ वार फॉर ऑल कंट्रीज ते ऊपर किछि माने आपण हाइलाइट करी किछि अछि
जे टिके अबे सेंसर लागी छे तो सबु बैंड रो अलगा अलगा एप्लीकेशन जो वेवलेंथ बैंड जो सबु बैंड रो अलगा अलगा एप्लीकेशन से गोटे एग्जांपल बैंड 1 वाटर बॉडी पाई बैंड 2 green reflectance of vegetation, band 3 plant discrimination, band 4 vegetation types, band 5 soil moisture content, vegetation moisture content, band 6 vegetation stress analysis, thermal mapping, band 7 geology and mineral. तो रिजोल्यूशंस तो आपण मान को जणा अछि सेंसर 4 प्रकार रिजोल्यूशंस spatial resolution, spectral resolution, temporal resolution, radiometric resolution. Spatial resolution, the smallest feature that can be detected. Jamiti 40 centimeter, that is the spatial resolution. Spectral resolution, number of bands. जदि गोटे सेंसर जदि 7टा बैंड रे ये करूछि डिटेक्ट करूछि that is the spectral resolution. वेवलेंथ रेंज गुडा को बेसरा स्पेक्ट्रल रिजोल्यूशन ले सेरा आसे आउ टेम्पोरल रिजोल्यूशन जोटा हम रिविजिट पीरियड भी कहूछु एटा मु रिविजिट पीरियड मींस केते दिन परे गोटे सैटेलाइट सेम एरिया को कवर करिवो जदि 10 डेज सेटा से इक्वेटोरियल पाई इक्वेटोरियल सबले फिक्स्ड किंतु से सन सिंक्रोनस नियर पोलार से तो मूव करूछि अर्थ भी मूव करिछि किंतु किछि दिन परे से सैटेलाइट सेम एरिया ऊपर मूव करिवो आज जेमिति हला 23 तारीख जदि गोटे सैटेलाइट रो जदि ए रिविजिट पीरियड और टेम्पोरल रिजोल्यूशन 5 दिन आज जदि रांची ऊपर से जदि पास कला ताहले 23 + 5 28 28 तारीख से पुणी पास करिवो तले एबे आपण पचारिबे काली जदी बन्याटे हो केमिति जणा पड़िबो सेति पे वी हैव टू साइन protocol with the other countries that they will provide our data and we will provide them data. So that almost now every 1.5 hour you can get information for any area of the earth. Thousands of satellites are there. Iran, Iraq, Bangladesh, Nigeria, समस्तଙ୍କର निज निज satellite ଅଛି. But India is now becoming a commercial partner. Last year तो India 100 satellites पठेला ना गोटे रॉकेट रे 108टा ना 108टा पठेला एंड fully successful. हाँ ता आगुरु पड़ी जेते से जियो स्टेशनरीटा तो रेडियोमेट्रिक रिजोल्यूशन जेमिति एटा तो आपण माने जानि छथि 2 बिट 3 बिट 8 बिट 10 बिट माने सेम एरिया ग्राउंड रे केमिति 2 लेवल्स और 2 बिट मींस सबु वैल्यू गुडा को 0 and 1 0 or 1 2 bit means 0 1 2 3 3 bit means 0 to 7 4 bit means 0 to 15 so the total number becomes 16 8 bit means 0 to 255 the same area on the ground 2 level रे 2 bit रे एमिति दिसिबो 4 level रे एमिति दिसिबो 8 level रे एमिति दिसिबो 16 level रे एमिति दिसिबो so greater the resolution radiometric resolution better will be the detection or discrimination capability of that sensor satellite through हमें 3-dimensional mapping भी करी पारो 3-dimensional mapping that means we can create the height and the depth of the earth surface also केमिति तार concept है एमिति जे एटा गोटे satellite same satellite this is the earth एटा earth हैला एई दिन first दिन satellite एमिति move करूची ए टू ए direction में move first दिन satellite एतिकी area cover कला second दिन एई पटरु satellite एमिति cover कला so we are getting 2 images for the same area from first day and second day when we fuse these 2 images they give you 3-dimensional information now 3D movie गुडा को same concept जो चश्मा में पिंधुछु से माने बेसिकली से जो सीन गुडा को से माने दुईटा ये कैमरा रे से माने शूट करंती गोटे सेई फोटो गोटे एई फोटो and they fuse it but you can see that fused image only when you wear that particular spec आमे भी आम डिपार्टमेंट रे काम होए गुडा को पिला माने करंती एटा we have practicals theory सब अछि एतरे तो এটা just example তাহলে এটা ଗୋଟେ real example France basically European space agency France এটা major contributor ଥିଲା spot satellite ସେମାନେ 3D information ଦିଅନ୍ତି इंडिया भी इंडिया रो भी निजर भी satellite ଅଛି ଏବେ 2-4 वर्ष लानी तो एई बोले देखो गोटे सेम एरिया केते दिन रे ସେମାନେ कवर କରୁଛନ୍ତି you can get the relief information relief माने कोन किछि चेंज जदी होउছে से जमी ऊपर height जदी due to some reason you can get that information from the satellite almost up to 1 meter accuracy 1 meter accuracy यदि आज यदि बिल्डिंग यदि भांगी गला कि तल को पड़े गला फर्स्ट फोर्थ फ्लोर पड़े गला ताले yesterday data and tomorrow data we can compare and find the height and find that building has collapsed गछ गुडा को जली गला गोटे जगह रे तो पूरा एस हो खार हो सब पाउस तो से हाइट 30 मीटर थिला कि 15 मीटर थिला एबे हाइट 0 हो गला कहीं गछ सेठी नाही सेति पय ए बलिया इमेजिंग करा हुए सो रिमोट सेंसिंग इमेज केमिति दिसे ए बलिया दिसे आ कोन दिस इज वन बैंड सेकंड बैंड थर्ड बैंड फोर्थ बैंड ए गुडा को every element is a pixel ratio reflectance schema emittance value गुडा को अछि and they represent different features on the ground surface, earth surface. So what we do is that we collate them and we use these techniques which are discussed in the previous class. The segment, gote road, gote road ki canal ki kichi gote linear ki non-linear features, sharp features. We apply detection technique, other kind of techniques to detect that. Techniques are more or less same. But these days, nobody is developing algorithm. सब तो पाइथन आर एसपीएसएस सब मिलुछि पिला माने आ से किछि लेखा लेखि करू नांती दे नो हाउ टू यूज दैट चैट जीपीटी रे जई कहि देबो हाउ टू ओरे पिला देखै भी देला से मते आई हैव यूज्ड चैट जीपीटी फॉर मैथेसिस आ से मिस्टेक फ्री नो प्लेजरिज्म the the different applications of two types of satellites geosynchronous or equatorial weather forecasting rainfall snowfall cyclone tsunami thunderstorm भी हमें measure करी पार्थ lightning dust storm tornado wildfires landslides flood drought ଏବେ ଆପଣ ପଚାରେ flash ने cloud burst को कहीं की research cloud burst in the hilly region they develop so instantly that condensation of moisture there in 30 minutes and for that we need other kind of techniques no doubt 30 minutes रही है ना cloud burst 30 minutes से moisture condense होची density बढ़िला पड़िला से थी और प्रे forecasting is an issue no doubt but detection is possible. How many lightning are taking place all over the world? We have detectors. We have data. Every half an hour we have data. Forecasting in which condition lightning will occur, it is a meteorological event. Yes, probability ହେବ probability तो कहू छु किंतु लागू नहीं बेसी किछि सेथिरे that is another parameter. Land parameters, surface temperature, evapotranspiration, atmospheric humidity, wind direction and wind velocity भी measure करी होछि. Wind direction and wind velocity, atmospheric pressure and temperature, telecommunication, mapping of earth resources. With the basic mapping, sun synchronous satellite through the web, resource, non-human resource, human resource, water, land, vegetation, soil, atmosphere, disaster, landslides, flood, drought. And these are some of the other information which we can measure. Biological, bacteria, coliform, algae, temperature, turbidity, clarity of water, salinity, dissolved solids, suspended solids, pH, DO, biological oxygen demand, chemical oxygen demand, odor, tints, color, floating matter एगुड़ाक भी आजिकली hyperspectral remote sensing रे measure करा होछि. So this is all about a brief introduction to remote sensing. After this, all these techniques which the speakers have elaborated, we use them. We are using fractals also these days. Thank. But these are basics. And sensor part is by the electronics people. Yes. You remain involved, who stops you? It will be major. This is the major challenge. I do not know.
बहुत बढ़िया सेशन थिला
Thank you.
टाइम सेशन माने सर एकदम बढ़िया टाइम रे फिनिश कले हम तरफ बहुत बड़ा धन्यवाद आउ गोटे थरा कर करे आउ मु सर को अनुरोध करी सर आप फ्रंट पर्सन टू प्रज्ञा मैडम को अनुरोध करी Thank you.
आमे आउ मु बेसी मिनिट नेबिनी मैक्सिमम 5 मिनिट खाली सभा आउ सेमिनार समाप्त करिया पाइका जो प्रोसेस अछि जो डेकोरम अछि मु ता पाइका एई वैलिडेशन सेशन रो मुख्य अतिथि प्रोफेसर मेहर को